Okay, last time we talked about what a variable is in the statistics sense of the word, but now we're going to talk about some of the different kinds of variables there are and the different types of data and ways data can be classified. Remember, a variable is something that can vary from one individual to another, like number of pets somebody has, favorite pizza topping, number of hours of sleep somebody got last night, a college student's major. And you may have noticed that some of these are numbers. Some of these have values that are numbers, and some are not numbers, like favorite pizza topping or a student's major. So that's one way we can classify variables. Some variables are numbers, some aren't. And so we say that some variables are qualitative and some are quantitative. So a qualitative variable, spelled with an L, like quality, is one that's not a number. It's just which of several categories something falls into, like a major or a pizza topping, or whether or not somebody owns a graphing calculator, or what presidential candidate somebody supports. And then a quantitative variable with an N, so that's a quantity. It's a number, an amount. It tells how much or how many or how long of something there is. And that can be divided further into a discrete or a continuous variable. A discrete variable is one that has to be a whole number because you're counting how many of something there are. Like how many pets somebody has. Might be 0, might be 1, might be 2, might be 12, but it can't be 6.5 or 3.87 or 5 2/3. So a discrete variable is one where you're counting how many of something there are. And then a continuous variable is one that you get by measuring. That tells you how much of something there is. So it could be any value, not necessarily a whole number, like how many hours of sleep somebody got. Now, when I asked you how many hours of sleep you got, most people do give me a whole number of hours. They say they got 6 hours or 8 hours, or they might say something like 7.5 hours. But if I stood by your bed with a stopwatch and timed exactly how long you slept, it might be, say, 7 hours and 23 minutes and 16.27 seconds, depending on how precisely I measure that. It doesn't necessarily have to be exactly a whole number. So when you measure how long or how heavy or how much of something there is, and it doesn't necessarily have to be a whole number, that's a continuous variable. So to test our understanding, first of all, are we talking about a qualitative or a quantitative variable when we talk about height of children in a kindergarten? We measure them to see how tall they are. Yeah, that would be quantitative. That's a number, a quantity. What about classification of employees as full-time, part-time, or temporary? Okay, that guy's full-time, that person's part-time, and so on. That would be qualitative with an L. That's a quality, but it's not a quantity. It's not a number. Now, discrete or continuous. Would we be talking about a discrete variable or a continuous variable if we were talking about the amount of time needed to eat a pie in a pie eating contest? That would be continuous. Whatever it's measured in, minutes or seconds or whatever, it doesn't necessarily have to be a whole number. What about number of patients seen by a doctor each day? That is discrete. It does have to be a whole number. What about number of piglets a mother pig has? That would be discrete. What about the length of a screw in centimeters? That would be continuous. And one reason this is important, one reason we care, we care whether a variable is qualitative or quantitative, because if it's quantitative, then we can do calculations with those numbers. We can say what the average is, what the standard deviation is, what the total value for a bunch of different values is, what the highest or the lowest value is. We can't do those sorts of things with qualitative variables. And then we care about the difference between discrete or continuous variables, because with continuous variables, they are rounded, and we have to worry about, are we talking about something that's been rounded to the nearest whole number or the nearest tenth or what? So like if we say that the length of a screw is 5 centimeters to the nearest whole centimeter, it might not be exactly 5 centimeters, it might be a little more or a little less than that, but it's closer to 5 than it is to 4 or 6. So that would mean that it's somewhere between 4.5 and 5.5. If it was any less than 4.5, it would round down to 4. It would be closer to 4 than to 5. And if it was any bigger than 5.5, then it would be closer to 6 than it was to 5. So we would say that the boundaries on 5 centimeters would be 4.5 to 5.5. That's the range of values that if you round it to the nearest whole number, it would be 5. So the boundaries on a value are the range of values before rounding that would result in that particular rounded value. For example, if you take any number between 22.5 and 23.5, as long as it's 22 point something bigger than 5, or 23 point something that's smaller than 5, like 22.8 or 23.392, and then you round it to the nearest whole number, what you end up with is 23. So the boundaries on 23 would be 22.5 to 23.5. The boundaries on 2.06 would be 2.055 to 2.065. So 2.06, if that's the result of rounding, then something has been rounded to the nearest hundredth, to 2 places after the decimal point. So that means before rounding, either you had a 2.05 and then the digit after that was 5 or bigger, or you had a 2.06, but then the next digit after the 6 was smaller than 5. So let's try some examples, test our understanding. What are the boundaries of 63 miles? And whenever I ask you a question like this, if you want to pause the video and think about your answer, you certainly can do that, and then unpause it and see if what you thought the answer was matches what I say it is. So if you need a little extra time to think, pause now and then unpause, and I'll tell you the answer is 62.5 to 63.5 miles. What are the boundaries of 5 foot 7 inches? Answer, 5 foot 6.5 to 5 foot 7.5, or 5 foot 6.5 to 5 foot 7.5. What are the boundaries of 3.8 ounces? Answer, 3.75 ounces to 3.85 ounces. Notice that the boundaries always end in a digit of 5. That's because the boundaries are always halfway between one number and another number. And if you write half in decimal form, it's got a 5 after the decimal point. So halfway between 3.7 and 3.8 would be 3.75. Halfway between 3.8 and 3.9 would be 3.85. So anything between 3.75 and 3.85 would be closer to 3.8 than it would be to some other number like 3.7 or 3.9. That's why the boundaries on 3.8 are 3.75 to 3.85. Now we're going to talk about the different scales or levels of measurement. So this is a little bit like the difference between a qualitative and a quantitative variable, but it breaks it down a little more into nominal, ordinal, interval, or ratio level data. So nominal level data is where your data are just sorted into categories that are not ranked in any particular order. So if you classify people according to whether they're male or female, or according to what racial or ethnic group they belong to, or according to whether they're married or single or widowed or divorced, or according to what zip code they live in. Even though a zip code looks like a number, it's not really telling you how much of something there is. It's just a label assigned to a particular geographical area. Ordinal level data is where the data are ranked in order, but there are not precise numerical differences between the different classifications. So if you rate the service in a restaurant as either poor, fair, good, or excellent, there's a definite order there. Poor is worse than fair, fair is worse than good, good is worse than excellent, but there's not precise numerical differences between those. If you write an essay for an English class and it gets a letter grade, A, B, C, D, or F, that would be ordinal. Movies being rated as G, PG, PG-13, R, or NC-17, that would be ordinal. There I've got them rated from most family-friendly to most adult. But you can't necessarily say that every PG movie is exactly equivalent to every other PG movie, or you can't measure the precise numerical difference between G and PG, or between PG and PG-13. Interval level data. Now we are getting into actual numbers. So interval level data is where you are talking about numbers. Data are ranked in order. There are precise differences between units, but no meaningful zero. There aren't a whole lot of different examples I could give of interval level data, but one good example would be temperature, measured in either degrees Fahrenheit or degrees Celsius. So 90 degrees is hotter than 80 degrees, which is hotter than 70 degrees, but you don't really have 0 degrees that means no temperature at all. It's just a particular point on the temperature scale. If you do have a meaningful zero that really does mean nothing of that thing, then you're talking about ratio level data. So with ratio level data, 0 really does mean none at all of the thing you're measuring. And that means that if one number is twice as big as another number, you really do have twice as much of that thing. So height, weight, amount of time, number of children, those are all examples of ratio level data. So one person who's 6 feet tall really is twice as tall as another person who's 3 feet tall. And if somebody was 0 feet tall, that really would mean no height at all. Weight, 0 pounds really does mean no weight. And somebody who weighs 200 pounds really is twice as heavy as somebody who weighs 100 pounds. Somebody who has 6 children really does have 3 times as many children as somebody who has 2 children. And somebody who has 0 children, if that's the number of children, that really does mean they have no children. So which would it be if we were talking about number of years of teaching of experience of elementary school teachers? That would be ratio level data. If somebody has 0 years of experience, that really is no experience. What about sizes of t-shirts? Small, medium, large, extra large? That would be ordinal. What about colors of cars on a car dealer's lot? That would be nominal.